Right, okay, so let's go through the solutions here. So first of all, question 1, evaluate 2 cubed plus 2 to the 4, all to the minus 2. Well, 2 cubed is 8, 2 to the 4 is 16, and 16 to the minus, so we've got to the power of minus 2. 16 and 8 is 24. So this is 1 over 24 squared. Now, what's 24 squared? 24 squared is 2 4s are 8, 2 2s are 4, 4 4s are 16, 2 4s are 8, 1 is 9, 6 here, 7 here, 5 there, 576. 1 over 576. Question 2. Write 600 million in standard form. 600 million is 3, 1, 2, 3, 4, 5, 6. 600 million. So we need to move the decimal point from here. 1, 2, 3, 4, 5, 6, 7, 8 times. 6 times 10 to the 8. Question 3. Simplify 8a to the 9 to the 1/3. Now we should remember that we can split this up into 8 to the power of a third, a to the 9 to the power of a third. Well, 8 to the power of a third is the cube root of 8, and a to the 9 to the 1/3, we multiply these powers together. 9 times a third is 3, so this is a cubed. Cube root of 8 is 2, so we get 2a cubed. Question 4. If d is halved, well, if we halve d, we're dividing by, therefore, half of what we used to, and dividing by a half is like multiplying by 2. So y would be twice as big. Twice as large. Question 5. What is 25 as a percentage of 15? So what is 25 as a percentage of 15? So what we need to do here is we need to think about 25/15. What's that? So that's 5/3. So 5/3, what is 5/3? So 5/3 is 1.6 recurring. So we need to multiply that by 100 in order to get this as a percentage. So we've got 166.6 recurring percent. And to the 3 sig figs, this is 167%. Question 6. Find the nth term of these. Right, so they're going down, they're going up in 4. So the common difference is 4. So we've got 4n, and then the 0th term is the term that would go here. So this needs to be minus 44. So we've got minus 44 here. Question 7. Factorize 4y squared minus 64. Well, first of all, 4 is a common factor. So we could take 4 out as a common factor, and therefore we've got y squared minus and 16. Now we've got a difference of 2 squares here. So we've got 4. Remember, a difference of 2 squares, 2 brackets, y, 4, 4, plus and minus. Question 8. Simplify root 6 to the 4 minus root 6 to the 6. Well, the easiest way to do this is to use laws of indices. So root 6 is 6 to the half to the power 4 minus 6 to the half to the power 6. And we multiply these indices together. So 4 times a half is 2. So this is 6 squared minus, and this is 6 cubed. So this is 36 minus. Now what's 6 cubed? 6 cubed is 36 times 6. 6 6 is 36. 6 going 3. 3 6 are 18. 21. 216. So we've got 36 minus 216. What's that? 6 minus 6 is nothing. Borrow 1 here. 880. So we've got minus 180. Question 9. Multiply at the brackets here. So we've got 14x minus 49 plus 4 is 2x. Subtract 2x from both sides. So we get 12x, and we're going to, minus 49 plus 4 is minus 37. That's equal to 0. Add 37 to both sides, and divide both sides by 12. Okay, question 10. Find the area of a semicircle with radius 9. So we know that the area of a circle is pi r squared. So the semicircle is pi r squared over 2. So this is pi times the radius is 9. So 9 squared is 81 over 2. So we got 81 over 2 pi. Question 11. 3 unknowns, x, y, and z, have all been estimated to the nearest integer. Okay, so write down the inequality for the bounds of each. Okay, so we're starting off with a here. Oops. A. Write down the bounds of each of x, y, and z. Well, if they're to the nearest integer, we need to share that integer across this inequality. So this is going to be whatever x was minus 0.5 to x plus 0.5. So whatever this value in the middle is, we're going to the nearest integer. We need to subtract a half from each side. And then for y, we've got the same thing. So this is y plus 0.5. And of course the same thing for z. So we've got z minus 0.5 less than or equal to z less than z plus 0.5. Okay, that's the first bit done. So part B now. Hence calculate the minimum value of x plus y plus z if the rounded numbers add to 100. Alright, so the rounded numbers add to 100. So we know that the rounded numbers are x, y, and z. So x plus y plus z equals 100. That's what we're told. And what about the minimum value? Well, the minimum value are all these smallest values added together. So here we've got x minus 0.5 plus y minus 0.5 plus z minus 0.5. So that's my minimum value. Well, we've got, this is now x plus y plus z. And we're going to subtract 3 lots of 0.5, which is 1.5. But what's x plus y plus z? We know it's 100. So this is 100 minus 1.5, which of course is 98.5. Question 12. We're going to do this on the graph. So this is a little bit like y equals mx plus c. The q is x and the p is y. Remember this number here, this is the y-intercept, so it's going to go through a y-intercept, or in this case a p-intercept of 7, and the gradient is 3. So we're going to go 3 down, so from 6.5 to 3.5. Oops, sorry, from 7, I beg your pardon. Down 3 to 4, and then across 1 to this value here, and then we're going to draw that through there. So remember, our rise over our run is going to be 3 over 1. Question 13, did 12 on the graph. 2 solids A and B are similar. Okay, so the lengths of B are 4 times the length of A. So the scale factor of lengths is 4, it said. And hence the areas are 4 times bigger for B than A. Also, comment on the validity. Well, actually, we should know that the scale factor of areas is 4 squared, okay, which is 16 times bigger. Okay, so not 4 times bigger, not true. Right, okay, next one, question 14. Calculate the roots of 6x squared plus 11x minus 10 equals 0. So we're going to factorize multiples of 10. Well, we've either got 10 and 1, and multiples of 6 are perhaps 2x and 3x. Let's see whether that works. 2x times 3x is 6x squared. Here we've got 20 and 3, so that's not going to work. So 10 and 1 aren't going to work. If I try 10 and 1 the other way around, again, I'm going to get 2 here and 13 here. 2 and 13, that looks like it might work. So how do I get plus 11 from 2 and 13? So I want to add the 13 together and subtract the 2. So here's subtracting the 2, and here's adding the 13. Let's just check that. 2x times 3x is 6x squared. 2x times minus 1 is minus 2x plus, that's 30, not 13, I beg your pardon. So that's not right. So let's go somewhere else. Let's try 3x and 2x, and let's try 5 and 2. 6x squared. Here we've got 15 and 4. That could possibly work, 15 and 4. So let's have a look. So we want plus 11, so we're going to have plus 15 and minus 4. Let's see if that works. 3x times 2x, 6x squared. 3x times 5 is 15. 15 minus 4 is 11, so that's correct. And minus 2 times 5 is minus 10. Yes, that's correct. So that's a good indication. You should always multiply it out to check it afterwards. So we've got two things that multiply together equals 0. So the only way that can happen is this either bracket is 0. So that's 0 or that's 0. So if we solve this one, we get 3x equals 2. So x equals 2/3. And if we solve this one, we get 2x equals minus 5. So x equals minus 5/2. Question 15. I'm not going to do that one on here. Draw a graph, and I might do it later if I've got time, so I'll just miss that one out for a minute. Rush for time. Given the following information, waiting times at a doctor's, calculate the mean, the median class. Okay, so first of all, the median is the n plus 1/tooth value. Okay, now what's n? Well, n is the number of people. So how many we've got here? 11. 11 plus 17 is 28. Plus 6 is 34. So the 34 people. So this is the 34 plus 1, which is 35/tooth value. Which is, and what we've got, half of 35 is 17.5th value. And we need the cumulative frequency here. This is the frequency, the number of people. So cumulative frequency, add the frequencies up. 8 and plus 3 is 11. Add the 17 makes 28, and add the 6 makes 34. Where does the 17.5th come? That goes there, in between 11 and 28. So we go along, and it must be this class here. So this is the 15 less than t less than or equal to 25 class. So that was part A. Let's do part B now. Calculate an approximation for the mean. Right, so to approximate the mean, we need to do the mid-class value as our approximation for x. So this is going to be 2.5. This is going to be halfway between 5 and 15 is 10, and halfway between 15 and 25 is 20, and halfway between 25 and 30 is 27.5. So our mean, which is d bar, is the sum. We need our, this is our x value. We need our xf values now. So let's work those out. So 2.5 times 8. So what's that? Let's just do that over here. 8 times 2.5. 8 times 40, not quite 4, 16, 20. So that's 20. 11 times 10 is 110. XF, sorry, so 3 times 10, sorry, is 30. And then 17 times 20 is 340, and 6 times 27.5. Okay, 6 times 27.5. 27.5 times 6. 6 5 is 30, okay, 3. 7 6s are 42, plus the 3 makes 45. 5 carry 4. 2 6 are 12, plus the 4 is 16, so 165. So the average now is the sum of the x, well, it's not the xf, I suppose it's the tf, so these should be t's, aren't they? Not x. tf, sum of tf divided by the sum of t. So we need to add these all together. What we've got here, 5, 2, 5, 9, 9 and 6 is 15, 5 carry 1, 3, 4, 5. 555 divided by the sum of t, which is 34. Okay, whatever that value is. Typically, actually, this question is probably more likely to be calculator paper, but never mind, you get the idea. C, draw a histogram. Well, for a histogram, we need to find the frequency density and the class width. So we do the class width. This is 5, and this is 10, and this is 10, and this is 5. And then the frequency density, remember the frequency density is the frequency divided by the class width. So we're doing the frequency, 8 divided by the class width, so 8/5. And the frequency is 3 divided by 10, it's 0.3. 8/5, by the way, is 1 3/5, which is 1.6. And frequency divided by class width is 17 divided by 10 is 1.7. And 6 divided by 5 is 1 1/5, which is 1.2. So basically, obviously you'd be given some graph paper here. You'd have your frequency density going up here, and then you have your t's here. T's are going from 0 to 30. So 5, 10, 15, 20, 25, 30. And your frequency densities are going all the way from nothing up to 1.7. So let's just do, so there is 0.5, 1.0, 1.5, and that's 2.0. So let's do our first class. 0 to 5 has got a frequency density of 1.6. 1.6 is there. Obviously, this will be much more accurate. And then 5 to 15, sorry, has got a frequency density of 0.3. So 0.3 is there. So that's going to look like that. And now we've got 15 to 25 has got a frequency of 1.7. So 1.7 is up here. 15 to 25 to 1.7, sort of there. And finally, we've got 25 to 30 is 1.2, so 1.2 is here, and it looks like that. Okay, so now D, draw a cumulative frequency curve. Now remember, a cumulative frequency curve, you've got the cumulative frequency here, the upper axis, and the upper class boundaries of T here, or X, T in this case. So now we're going to plot. So they go from 5 up to 30 again. So 5, 10, 15, 20, 25, 30. And the cumulative frequencies again go from up to 34. So let's make that the axis there. 34, so we should do that. 10, 20, 30, 40. And we plot the upper class boundary. We start off at 0, 0, by the way, there. And we plot the upper class boundary, so that's going to be 5 against the cumulative frequency, which is 8. So 5 against 8, so that's that point there. That's 8. This is 5. And now we do 15, this value here, 15 against the cumulative frequency of 11. So 15 against 11. And now we do 25 against cumulative frequency of 28. So 25, so all the way there to 28. And then finally 30 against 34. 30 against 34, which is about there. And we join those up. Again, this would be much more accurate like that. And hence we're going to use a box plot. And our box plot is the lowest value. Now the lowest value is 0 up to the highest value, which is 30. And we're going to do, remember this goes up to 34, so halfway up 34 is 17. You're going to go along there and down there for Q2. So that goes that. Halfway up, a quarter way up 34 is, what's 34 divided by 4? So 4 to 34 is not 4 to 34. 4, is it 8? 8 is 16, 32, yeah, 8. So it's 8 point, 8.4 into 25, 8.5, okay. So we're going to go up to 8.5 along and down. So this would be our Q2, and then Q3, we're going to go 3/4 of the way up 34. So that's 3/4. A quarter is 8.5, so 3/4 is 24, 25.5. So that's going to go along to there and down. You'll get much nicer numbers in a non-calculator paper, but that will give you that there, and then you go along and you draw your box plot. And by the way, you put the values on here. So this would be 30, this would be 34, this would be just over 20, perhaps 21. This one would be just under 25, perhaps 24, and this one is 5. Okay. Obviously, be far, far more accurate. And E, oh, that was E, drawing a box plot. There we go. Okay, 17. Expand and simplify this. So first of all, we're going to square this out. So you could multiply the two brackets, but I'm going to square the first, 4x squared, double the product of 1 and 2x. Well, 1 times 2x is 2x. I'm going to double that to 4x. Square the last. 1 squared is 1. And I'm going to multiply that with x minus 3. And now I'm going to multiply this out. So 4x squared times x is 4x cubed. 4x squared times minus 3 is minus 12x squared. That's that one. Now this one, 4x times x is 4x squared. 4x times minus 3 is minus 12x. Now these 1x and minus 3. And then I'm going to tidy this up. So I'm going to get 4x cubed. X squared is now minus 12 plus 4 is minus 8x squared. Minus 12 plus 1 is minus 11x, and then minus 3. Shade the regions corresponding to A union B. So A union B is the union of all those. That's that. Zoom in a little bit here. A intersection B, that's the bit in the middle. And A intersection not B. Well, we want, where does A, well, A is this. That's A. And not B, let's do that in green, is everything outside of B. So where do the two coincide? It's this bit here. So where do those two overlap? It's that bit. Now A union B, not. So this is the complement. Remember, so not A union B. Well, A union B, as we saw for part A, is that. So it's basically not that. So that's going to be everything outside of the two rings, like that. Question 19. The number of lightning bolts in the sky in a certain town was written down in the course of a week as that. Work out the mode. So the mode, well, the zeros seem to be the mode. So the the modal answer is 0. The mean, we need to add them all up and divide by however many there are. There are 14 of them. Let's see how many we've got here. 1, 3, 7, 10, 36, 37, 38. Divided by 14. I'll cancel that down, perhaps 19 sevenths. And the median, well, we need to put them in order. How many zeros have we got? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. How many ones we got? 1, 2, 3. 1, 2, 3. How many twos? 1. How many threes? 1. How many fours? 1. And how many 26s? 1. Okay.